Hello everybody, this is Mrs. Snook with section 6.3, proving that a quadrilateral is a parallelogram. So before we finished first semester, the last thing we did was we had a parallelogram and we could make certain statements about the lengths of the sides, about the measures of the angles, and about the diagonals. That was starting knowing that it was a parallelogram, so therefore we could say these things. Today, we're going to go the other way. We don't know that it's a parallelogram. We do know that it has four sides, and there are certain properties that we can look for that would then prove that we have a parallelogram. So let's go ahead and get started. First is a quadrilateral with opposite sides parallel guarantees a parallelogram. So if those two sides are parallel, and the top and bottom are parallel, then you have a parallelogram. And the way I'm going to write it for the shorthand is I'm just going to say quad with opposite sides parallel, so I'm using that parallel symbol. The arrow means implies, and then I'm just going to draw a parallelogram. So quad with opposite sides parallel implies a parallelogram. Same thing if you have opposite angles congruent. So look at this one. Those two are opposite angles, and if they are congruent, and if those two opposite angles are congruent, then we have a parallelogram. Our third one, this one's kind of interesting because we didn't really have something similar in our last section. So a quadrilateral with a pair of opposite sides that are parallel and congruent at the same time. That right there is enough for a parallelogram. So for instance, those two sides parallel, that's not enough. But mark them congruent. I now have guaranteed that this quadrilateral is a parallelogram. And I didn't have to do anything with other sides. That's what's neat about this one. Quadrilateral with supplementary consecutive angles implies a parallelogram. So think back to our last section. If it was a parallelogram, we knew that their consecutive angles were supplementary. If the consecutive angles are supplementary, we know it's a parallelogram. So I'm going to do this like this. I'm going to call this A, B, C, and D. So angle A plus angle B equals 180. That means you have a parallelogram. Or angle B plus angle C equals 180. Or angle C plus angle D equals 180. Or angle D plus angle A equals 180. So if you have these supplementary consecutive angles, you've got a parallelogram. So that's our fourth one. Our fifth one is the quad with opposite sides congruent is a parallelogram. Now we knew that before. We knew that parallelograms have opposite sides congruent. Works the other way. If the opposite sides are congruent, you can guarantee a parallelogram. So if those two are congruent, and those two are congruent, we've got a parallelogram. Last one refers to the diagonals, and this one says that if those diagonals bisect each other, you've got a parallelogram. I'm going to put a little point here, E. So if it just so happens that line segment BE is congruent to line segment ED, and line segment AC is congruent to line segment EC, you've got a parallelogram. So now that we have these tools in our toolbox, let's go ahead and we're going to look at some pictures. We're going to examine those markings, and we're going to decide if those are parallelograms, and then we'll write the justification. And I want you to take note of the shorthand I'm using for writing the justification. So first one, Determine if each of the following quadrilaterals has enough information for it to be guaranteed a parallelogram. I look at this first one, and I have the two line segments on the sides. Those are both parallel and they're marked congruent. So I'm going to say yes, and my justification is quad with opposite sides parallel and congruent implies parallelogram. Next one. Look at the way these diagonals are marked. Look very carefully. I see congruent there and there, so that diagonal was bisected. I also see congruent there and there, so the second diagonal was also bisected. So I do have both diagonals being bisected. So I'm going to say yes, quad with bisected diagonals, sorry, almost said dissecting, bisecting diagonals implies parallelogram. Now let's look at number 3. I have my top and bottom marked parallel, and I have my left and right marked congruent. But they're not on the same pair of sides. So this is not a parallelogram. And I'm just going to put a note, not on same pair of sides. Now, because this was not a parallelogram, you're not required to justify this. I just wanted to put that note there so that you would see why. Next one. Check this one out. I have right here, those two angles are congruent, and right here, those two angles are congruent. So I've got one pair of opposite angles congruent. Is that enough to say that this quadrilateral is a parallelogram? Pause this video and think about this, and when you come back, I'll tell you the answer. Okay, welcome back. So here's the thing, this one's kind of a trick. Check this out. We have reflexive property right here. So therefore, if I call this triangle 1 and that triangle 2, those triangles are congruent by angle side angle. That means that all their corresponding parts are congruent. So now I have opposite sides congruent. I also have opposite angles congruent. So either way. So quad with opposite sides congruent implies parallelogram. Just remember that's angle side angle. Or another reason you could use is quad with opposite angles congruent implies parallelogram. Isn't that cool? We actually had to go back to some of our chapter 4 information to do this one. So like I tried to tell you, just because we start a new unit, do not throw out your old learning. Keep adding to that toolbox. This is one case where we added. All right, now we're going to take a look at this four-sided figure. And instead of saying yes or no, it's a parallelogram, let's figure out what information we would have to add to guarantee it's a parallelogram. So first of all, we're told that AB is parallel to CD. And I'm giving you a hint. There's two possible answers. So there's two ways to do this. I'm going to highlight these two that we know that are parallel. Now, one way I could do it, I could add the information. So here is option 1. I could add in that AD is parallel to BC. That would then give me the opposite sides parallel. And so I'm just going to say quad with opposite sides parallel implies parallelogram. That's your first possible answer. Your second one is let's do this. Let's mark AB congruent to DC. Then we have one pair of sides that are both congruent and parallel. That's a congruent. All right, next one. Angle DAB is congruent to angle BCD. So let's erase these markings. Let's put in a new set. Angle DAB, that's this angle here, is congruent to angle BCD. That's this angle here. So I know I have one pair of congruent angles. The information that I could add that would guarantee that ABCD is a parallelogram is if I marked those two angles congruent. Then I've got opposite angles congruent. So I'm going to say angle ADC is congruent to angle, let's just say ABC. And remember, I have to use all three letters because there's multiple angles at point D and point B. So use all three letters. And this is going to be quad with opposite angles. Congruent implies parallelogram. Next one, line segment DE is congruent to line segment EB. So let's go ahead and mark our picture, DE and EB. So what we've done is we've marked a diagonal that has been bisected at point E. So if I'm looking at diagonals, then what I need is that other diagonal to also be bisected. Like that. So line segment AE is congruent to line segment EC, and that's going to be quad with bisecting diags. All right, next one. AD is congruent to BC. We've got two possible answers for this one. First one, go ahead and mark them congruent. Well, let's just do all four sides congruent. I mean, both opposite sides congruent. So let's bring in side AD and BC. Oh, I already did that. AD. Oh, I see. I marked the wrong. There, it's the sides, left and right side, that are congruent. So AB and DC. So AB is congruent to DC. Quad with opposite sides congruent implies parallelogram. The other option you could do, just like before when you had one pair that was both congruent and parallel, I can do the same thing here. Mark them parallel. So my second choice could be line segment AD parallel to line segment BC, quad with one pair, opposite sides, congruent, and parallel implies parallelogram. Last one. We have angle DAB and angle ABC. Add those together and they're 180 degrees. So DAB, ABC, those are consecutive. So I need some more consecutive angles. I could say angle ABC plus angle BCD equals 180. Those are now consecutive and supplementary. Now let's work our way around. Angle BCD plus angle, let's do CDA. So angle BCD plus angle CDA equals 180. That's the second pair of consecutive angles that they need to be congruent. and then angle CDA plus angle ABC. Angle CDA plus angle, some over here, CDA, sorry, DAB. So now, since I have all four pairs of my consecutive angles being supplementary, I have a parallelogram. So quad with consecutive angles supplementary implies parallelogram. Okay? Now let's do some more mathy stuff. Let's actually get some numbers and some equations going. So I have two parallelograms, and what I want to do is I want to find the values of x and y that can make those parallelograms, that can make those quadrilaterals parallelograms. Right now I do not know that they're parallelograms, but I do know they're four-sided figures, so they're quadrilaterals. So looking at the first one, I'm going to do A first. I know stuff about the angles. So I'm just going to go for opposite angles being congruent. So I'm going to say 2x equals 70, then x equals 35. Okay. Now I need to figure out y. I've got x, I need y. So let's do 3x plus 5 equals x minus 3y. Okay. Again, I'm just doing opposite angles are congruent. And I'm going to go ahead, because I know x is 35, I'm just going to go ahead and plug that in. So 3 times 35 plus 5 equals 35 minus 3y. So let's go ahead and do some combining of like terms and solve for y. 3 times 35 plus 5, so I get 110, equals 35 minus 3y. Subtract 35 from both sides. That's a plus. And I get 75 equals 3y, so then y equals 25. So what this says is when x is 35 and y is 25, both have to be true, we have a parallelogram. Now let's look at B. This time our information is about the diagonals. So I'm thinking that I'm going to use quad with bisecting diags. Okay. Let's write our equations. I have 3x equals 12, because those two have to be congruent. And for my other two, x plus y equals 5y. So let's go ahead and we'll solve for x. Divide both sides by 3, x equals 4. And now I'm just going to plug in the 4 and solve for y. 4 plus y equals 5y. So 4 equals 4y, y equals 1. All right, that's it for today's lesson. Thank you for watching and have a great day.